I believe the lines were down fully for 8 hours, and it ended up was a tens of millions, I believe, is what the overall price tag just in that 8 hours encapsulated. So it was a fairly significant event, all from one or two employees trying to do what they felt was in the best interest of the company.
Growing a business requires a holistic approach that extends beyond sales and marketing. This approach needs alignment among people, processes, and technologies. So if you're a business owner, operations, or finance leader looking to learn growth strategies from your peers and competitors, you're tuned into the right podcast. Welcome to the WBS Podcast, where scalable growth using business systems is our number one priority. Now, here is your host, Sam Gupta.
Hey everyone, welcome back to another episode of the WBS Podcast. I'm Sam Gupta, your host and principal consultant at digital transformation consulting firm Elevate IQ. Due to the proliferation of IoT devices in manufacturing environments, the number of access points prone to attack has increased significantly. And while the OT environments don't have as thicker code base as the IT environment, OT environments are less secure than IT. The lack of education in how to write production-ready software and a greater push for efficiency have been the reasons why OT devices are more prone to attack with higher safety consequences. In today's episode, our guests, Corey White and David Cundiff from Cyvatar, share their insights into how the trade-offs for greater efficiencies and OEE may be driving cybersecurity issues in the OT environments. They also take a deep dive into a car manufacturer's story where they ended up losing millions of dollars due to a ransomware attack within 8 hours of attack. Finally, they describe the mechanics of ransomware, how the codebase in OT and IT differ, and why OT devices are harder to secure and more prone to attacks than IT due to the lack of standardization and skill sets of OT operators. Let me introduce Corey and Dave to you. A 25 plus year veteran of security industry, Corey White has a deep understanding of the evolving nature of cyber risk. He founded Cyvatar in 2019 in response to the lack of remediation in the cybersecurity industry. As the industry's first membership-based cybersecurity as a service (CSaaS) company, Cyvatar's mission is to transform the way the security industry builds, sells, and supports cyber solutions. Dave is an information technology professional with a background in several industries, including manufacturing, software, and utilities. He has worked as a manager, consultant, and analyst with an inclusive focus in Microsoft and Unix based technologies. He can expediently learn new technologies and products and can provide proper scope and implementation of varied software and technologies. Dave comes to Cyvatar from Optiv, where he wore multiple hats, from managing multiple accounts to creating process flows to even executing training conferences. He did it all. With that, let's get to the conversation. Hey guys, welcome to the show.
Hey, how are you?
Appreciate it, Sam.
I am wonderful, and I am super excited to have you guys just because the kind of stories you guys have lived in, especially in the cybersecurity space, they are always going to be fascinating. But the most important part of those stories is the learning it is going to provide for all of us to be safe, secure, as a company, as a community, as a country. So thank you so much for coming on today. Do you want to start with your personal story and current focus, Corey?
Yeah, absolutely. My personal story, I've been doing cybersecurity the last 25 years, and my goal and this company that we built now is to actually democratize cybersecurity and get companies remediated and secure. So that's where I'm focused, because I felt like I've been failing in the past with all the incidents that Dave and I will talk about, where we haven't actually stopped them. So we're going to talk about the failures and how the industry can get better.
Okay, amazing. So, Dave, would you like to share your personal story and current focus?
Absolutely. I appreciate you having us. It's roughly the same as Corey. We've been working together in some way, shape, or form for the past 14 years.
Mm-hmm.
And just like Corey, my focus is getting ahead and actually preventing attacks and the issues that folks run into rather than responding to them and recovering from them. That's going to happen from time to time anyway, but the more we can get ahead of that and prevent it to begin with is my primary mission here.
Okay, amazing. So we are going to dig into all of that. But before we do that, we have one of the standard questions for all of our guests. So what is your perspective on business growth?
Sure. Honestly, with achieving growth, it's all about a matter of enabling the focus of what the business should be to move forward. Cybersecurity, where Corey and I have spent our careers, is generally the biggest impediment to most people's mind within their organization. And what we're really focused on is making sure that we attack cybersecurity in such a way that it is almost transparent to the end user, which enables them to truly focus on what that growth is for their business.
Okay, amazing perspective. Love it. So let's dive right into the story. I am pretty sure you guys have tons and tons of stories. So I'm actually going to start with you, Dave. So I know that you have worked with this car manufacturer that you actually wanted to share. So do you want to provide a little background about, what this business was and provide the backstory about the business? And then we can discuss their cybersecurity issues as well.
Absolutely. Absolutely. So, as with most car manufacturing organizations, there's a lot of disparate pieces that get brought together at one site to build the final product. This was one of the sites that brought everything together and had paint shop, body weld, all the engine building parts, multiple robots, disparate systems that did different controls, some Allen Bradley mixed with some Siemens, all the different types of controllers that are out there, bringing all that together, assembly lines running 24/7, hundreds of, really thousands of members of the workforce constantly moving. So any downtime for this organization at this site was costing them millions and millions of dollars. So very, very integral part of their organization, one of the largest sites within their manufacturing arm. And so that provided a lot of visibility at that site from upper management, from the hosting organ, or not the hosting, but the parent organization. As well, since generally manufacturing arms are divided into different divisions, areas of focus. So from top down, this had a lot of visibility for that organization. Very well run environment. They thought they had very good security in place, and in a lot of ways they did. They had really tried to make it a focus. Unfortunately, as people are wont to do, they try to find ways to get their job done more efficiently. So this goes back to the growth statement that we want to make security frictionless so the business can move forward in the way that it needs to move forward. Because whether we provide impediment or not, from a cybersecurity perspective, people who want to do a good job, they want to do well for the organization and the company that they work for, they're going to find ways to do things faster, in their mind better. They may not understand the security aspects of what they're moving around. So this particular site had office personnel, they had manufacturing personnel, there were third-party vendors on site that had different, I think a safety gear sales kiosk was on site. So there were food service folks, safety gear folks, just a bunch of different groups all working within the same area. And what that provides is a lot of complexity without understanding what that complexity means. So not only do you have the complexity of the manufacturing floor and the different systems doing different aspects, I mean, just the the difference between a body weld robot versus a paint robot,
Yeah.
and the controls and structure that goes in place there,
Yeah.
and being able to communicate that this vehicle is going to roll off of this line at this point in time,
Yeah.
and needs to move here within this window of time to hit the paint at the right time.
Yeah.
So all of that complexity on top of the standard complexity of an office environment, just extremely, it's a very, very choreographed dance,
Yeah. Yeah.
as we're all familiar with. And in this particular case, what had happened was a shared back-end storage device
Yeah.
was in place. And in order to make it more efficient and to save time and money for the organization, that shared storage device on the back end shared between both the business and the machine floor.
Okay.
So that way the office personnel could make updates to schematics and changes to that, and very quickly get that down to the manufacturing floor, so those schematics could be brought to bear within the focus of the assembly line and make those changes much more quickly, which ultimately, from a time perspective, made absolutely perfect sense. It was much faster. Problem was a device that was less than protected. It had security software on it.
Yeah.
The configuration was just such to where there was a little bit of a gap in its coverage. And that machine, obviously through no intentional malice, got compromised with a bit of ransomware.
Okay.
And as ransomware is wont to do, it will go from the machine to any of the network storage devices that it has access to, which then proceeded to lock down all of those shared schematics that a number of the manufacturing robots needed in order to do their job.
Yeah.
And then it transversed, because of that tertiary network connection from the network storage device into the protected controls network, it started to push over into some of the control systems as well. So PLCs, as the line controllers were actually starting to encrypt. Luckily, the organization was able to identify it fairly quickly. So it didn't actually encrypt an entire line, but with that in place, that brought that entire line down. Whether or not it encrypted the entire set of systems, it still brought the entire line down, because as you know, in manufacturing, if any one piece gets clogged up, it stops everything on the back end. So they were in a very difficult situation and trying to bring things up very, very quickly. So we actually came in and started working with them, making sure that we had clean systems to start from. So it was very much what was the minimum viable setup that we needed to put in place for those systems. We broke the connection to the office connectivity, so that way we could just bring up the network storage clean without that possible contamination vector, and actually work through finding where that minimum piece was that we could start building back from, and shutting down any of those pieces that had been infected very quickly, moving them off to the side, replacing with new hardware that had that minimum viable. So we kept the forensic data for recovery and reviewing, but really just making sure that, I believe it ended up being a dozen systems that were fully encrypted. I think there's probably, at this particular facility, there were probably between 2,000 and 3,000 devices just on the assembly lines that we had to go through and make sure, once we had the systems back up and running, we went through and did full forensics down the line to make sure nothing had carried over that we were unaware of, and we were making sure that we were continuing to do our due diligence to verify that there wasn't going to be future impact. Unfortunately, there were still a few other connections to the business network that we found through the course of that due diligence, where some additional difficulty was coming from, some more encryption that was trying to be pushed down as we brought connections back up. So it was a rather complex engagement. I think we ended up with about 20 folks on the ground working through this in order to get our hands around it as quickly as possible. And I believe the lines were down fully for 8 hours, and it ended up was a tens of millions, I believe, is what the overall price tag just in that 8 hours it encapsulated. So it was a fairly significant event, all from one or two employees trying to do what they felt was in the best interest of the company. It's really a lesson in understanding limitations.
Okay, amazing. And Corey, do you have anything to add to that story? Obviously, I have tons and tons of follow-up questions here, and I am actually going to throw them. Corey, did he miss anything? Would you like to add any colors to the story?
Yeah, I mean, you got to think about it from the perspective of Dave and team on the ground, those 20. So imagine from an incident response perspective, I'm back at the office coordinating, getting that many resources on site and responding to an ICS environment. So you need ICS expertise, you need incident response expertise, you need project management expertise to manage and coordinate resources. We ended up having resources working around the clock to make sure, hey, when one group got tired, another group could come in and fill in. So the coordination of that level of incident in literally a matter of hours is insane. You have to look at what that looks like. And then at the same time, I'm still communicating at the executive level with the executive status of how things are going. So it's the folks on the ground that are delivering, and then there's the executive execution piece that also has to happen at the same time, because when you're losing tens of millions of dollars, you get visibility at the highest level at any company.
Yeah, so amazing insights there. So my follow-up questions are going to be, obviously, there are going to be some clarifying questions, and then we are going to dig into the meat of the story. So first of all, I don't know if my listeners are going to be familiar with the ICS expertise or incident response expertise. It does sound like it's more of the crime scene, to be honest. Okay, but tell us, what do these ICS people do? What is their responsibility? Why are they required on the ground? Why do you have so many different roles? How do they coordinate? How do they work when there is going to be a situation like that?
Absolutely. So with ICS capability, I mean, just anytime you're rolling into a manufacturing environment or an environment with separate controls networks, there has to be a certain level of understanding of what those control systems do.
Okay.
And standard IT infrastructure follows very standardized rule sets. It's a matter of, we have Windows systems or Mac systems that provide Office functionality, and the Office functionality between a Mac system and a Mac system and a Windows system are roughly equivalent. You know how to use a word processor in one, you know how to use a word processor in another. With ICS, there's a lot of differentiation between controls environments. So I spoke about the differentiation between moving from body weld into the paint system just in this car manufacturing environment.
Yeah.
In that environment, you can have very different control modules, even on the same line. So understanding how an Allen Bradley produced control module versus a Siemens produced control module differentiates, and there can be a slight syntax differentiation, but that slight differentiation in syntax and how you code to one of those controllers can create a massive amount of issue, depending on what degree of specificity they have in, let's say we're talking about the speed of a fan controller. So you have a controller that's determining how fast a fan is going to run. If that controller has a specificity of the 100,000ths place, or, 4 points past the decimal, and another one has just a thousandths, place, then that if you code it incorrectly, you can vastly, exponentially increase the speed of that fan unintentionally, which becomes a safety issue. So having that level of understanding around ICS and what those controls networks do, what the types of environments you could run into is very, very critical whenever you're working with a manufacturing environment. Because you can definitely leave behind remnants unintentionally trying to clean up an issue or replacing something with a controller that's not necessarily a clean fit. So having that ICS experience and understanding the minor differentiation that can create an exponential change down the line in one of the plants or one of the lines that we're working on is very critical. So having that level of experience is absolutely integral to having a successful time to operation approach. From an incident response standpoint, there's standardized, and this is consistent across OT or ICS and IT environments.
Yeah.
Incident response is your standard 7-layer approach based upon NIST. You identify, you analyze, you contain, eradicate, remediate, and then learn and improve moving forward. So as you go through that process, the way you contain in an ICS environment versus an office environment, it's very easy for me to only contain a few devices within an office environment and have a specific scenario contained or a specific attack vector or compromise contained from that perspective. Whereas on a manufacturing floor, because of how interconnected everything is, depending on how flat the network is, and in most cases, in manufacturing, it's a very flat network, not very segmented, or it used to be that way. It's getting better as time moves on, but it used to be very flat. It was segmented from everything outside of the manufacturing floor, but once you got onto the controls network, it was very, very easy to traverse. As we move forward, though, folks are getting better and better at that segmentation of their networks. So that provides a much different scenario from a containment perspective, just for that incident response phase that is very different on a manufacturing or in an ICS environment that would be in an office environment or a traditional IT environment.
And this is very important for everybody to really think about the difference between an OT environment and an IT environment. Everybody in OT and ICS and manufacturing know that you should have, segmentation between both of them.
Yeah.
Because the scenario that Dave just talked about is that one incident on the IT side will lead to a whole manufacturing plant going down. The reality of it, everybody says we have a completely segmented. I've never seen it. It's an aspirational goal, but it's something that needs to be achieved because the attack is virtually always going to come from the IT side and then go over to the OT side and lead to a major compromise. And I think that's one of the challenges that we have as an industry is getting that segmentation right.
Okay, so a couple of questions. Obviously, I am going to have a lot more clarifying questions. Obviously, I am not the security expert, but I am the engineer. So I do understand a little bit about how these things work from the electrical perspective, from the mechanical perspective. Now, if I look at my ICS environment and when I look at the code base in the ICS environment, and you mentioned that, in the IT environment, things are slightly easier because you are going to have the operating system there. You are going to have the Microsoft Word in your Windows versus Mac. Now, if I look at the maturity of the code, the maturity of the code base that we have in both environments, if I look at my PLCs, my controllers, this code base is very primitive, very lean. Right. So I know that, Amici, you mentioned that, the syntax might be different. There might be a lot of different things that might be different in the OT environment. But when I look at more from the security perspective, my assumption would be you have a lot more failure point in the thick code because you have a lot more to attack there. So why is the OT environment slightly more challenging when you have far leaner layer to be able to penetrate? Can you tell me why that is?
That's an excellent question, Sam. I think because of the simplicity, it throws people off. To be perfectly honest, we're so used to the complexity of, oh, I have to jump through 15 hoops to get something installed on a Windows box here in the office. I mean, most of the operator systems that I've worked with in the past in manufacturing have been built on Windows in some way, shape, or form. Now the controllers and the PLCs on the back end are a little bit different, but the once the operator gets used to a specific aspect of it, they work well in it. But for whatever reason, and honestly, I now that you asked the question, I'm thinking through it, and I don't really have a good answer as to why most people have difficulty moving from an IT environment to an OT environment and being able to run significantly well there, because you're absolutely right. It is leaner. It's a lot more, I don't want to say primitive, because the level of complexity of how many pieces are under control of a single PLC, and just the number of aspects that can create a chain reaction. I think it's more an intimidation factor, because there's a real world effect if you change something on a PLC and it affects that fan that I spoke about before, and it speeds it up. There's a real world effect. There's lives at risk if something goes sideways in a manufacturing environment. I think it's more an intimidation factor now that I kind of think through it. I think it's more the intimidation factor of the real world implications rather than necessarily the complexity between the two.
Yeah, I mean, Dave, it's a combination of that plus the other component here. Think about it. The OT environment, in some cases, I've dealt with ones from the 80s, late 80s, early 90s. And so they don't have a proper TCP/IP stack. And so if you run a vulnerability scan against that environment, you're probably going to knock something over and take something down. So all the things you do in a standard IT environment, those do not apply in an OT environment. It just can't handle it. And so it's very, very sensitive. And then also the systems, sometimes there's those Windows systems. I've seen Windows 98 systems and Windows 95 systems controlling those. The updates of the OT environment doesn't happen on a regular basis like it does in a regular IT environment. So it's just much, much more sensitive. So that's why you'll never see an OT person letting an IT person operate in their environment, because the risk is just too high.
So I completely sort of get this idea that, in the OT environment, you are going to be, as I mentioned, that it's going to be slightly leaner, and in your IT environment, you are going to have the layers that are probably going to provide some sort of protection. In your OT environment, you are not going to have that protection, and I completely agree with you that in the OT environment, the implications are going to be far bigger, because you have your controllers controlling all of these devices, which can run over humans or whatever, just because your microcontrollers are really controlling those. But the point I'm really not able to get, to be honest, is why is OT environment harder to secure when you have lower amount of code to be able to secure there? So maybe you can describe to me how the ransomware typically attacks the surfaces. And in case of IT, they are actually attacking on specific ports, specific devices. And you also mentioned some of the encryption, right? So I don't know at what level are they trying to attack. Are they attacking more at the software level? Are they attacking at the hardware level? So can you touch on how their encryption is going to be? Are they attacking the encryption itself of the algorithm that my software or hardware may have provided? So can you describe how ransomwares typically think, and what do they typically attack in both IT and OT environment?
Absolutely. And I see where you're going now. With that, so again, when we're looking at the operator systems themselves, not necessarily the controllers or the devices controlling the line itself, but the operator systems, those are generally built on a Windows underlying system, maybe sometimes a Linux variant of sorts. But in most cases, it's a Windows underlying system. So the attacker can get a twofer. They can attack a Windows system in an Office device, and using those same underlying libraries, they can attack an OT environment, generally unintentionally. That in a lot of cases, that's not the focus as of right now. Now, there are specific examples of where attacking critical infrastructure or OT environments has very much been the focus. And I'll kind of pivot to that here in a moment. But in most cases, if we're talking the 80-20 rule, 80% of the time, it's a target of opportunity, so to speak, just because the underlying operating system of the operator system is similar to an office environment, so it's able to traverse. And if you think of it like a virus, in we'll not to put a pin on it, but the bird flu. It started in chickens and it traversed over into humans. So it's very much a similar jump. That compromise already exists for a Windows Office environment, standard IT infrastructure. And because the OT environment is quasi connected to the Office environment and runs with a very similar set of operating systems, it's able to do that bounce over into the OT environment. Now, the very targeted approaches, and the reason that it's so difficult to, it's not so much that it's difficult from a technological standpoint to secure a OT environment, because to your point, it's very lean.
Yeah.
There's a lot less to cover when it comes to protection in place.
Yeah.
In most cases, it's that friction. So like we talked about to begin with, when people look at cybersecurity, they look at it as an impediment for them doing their job. It is always security is always a slowdown. It always prevents me from doing my job faster, more efficiently. And when you're talking about, 8 hours costing tens of millions of dollars of downtime, seconds cost hundreds of dollars. I mean, seconds matter very, very much. So 5 seconds of slowdown, even if it's very important from a security standpoint, costs a lot of money for the overall organization. So that tends to be, it's a more political human friction than it is a technological friction to securing that operational environment.
Okay, amazing. Corey, do you have any follow-up comments on that?
Let's just say from the exec perspective, the visibility that you get when you're losing that much money that quickly is off the charts. I've been in meetings where these incidents and my team is on the ground. I'm in the board meeting literally with their board and their full exec team. So the pressure is enormous because there's so much money on the line. So that's just from my perspective where I'm usually playing, and Dave is on the more technical side. So it just is amazing the impact it has to an organization.
Okay, amazing. So I'm actually going to have one more follow-up question there overall with your comment related to the 5-second slowdown. So the way I am understanding and perceiving this is, this is the argument and debate and the political argument about, whether you want to write secure code or whether you don't want to write secure code. And that's where that 5-second friction may be coming from. So my understanding of this is going to be, let's say if I'm buying Siemens or Allen Bradley, I would guess that they already know the implications of these things. And if Siemens name is going to be associated with any of these attacks, obviously it's not a good feeling for them. So they would rather compromise on that 5-second. I don't know if they are trying to push the less secure code, but I am trying to understand the underlying reason. So when you say you are trying to save 5 seconds to push for your unsecure code in your OT environment, is that coming more from these devices? Is this the fault of the people who are actually writing the code in the OT environment, or is it really coming from the equipment provider?
Sure. I don't believe it comes from the provider. I mean, Allen Bradley, Siemens, whoever the vendor is, I guarantee you would say that they want the most secure code possible and you should absolutely protect systems. However, there is a trade-off. If we look at the level, especially in the past, when I first started in security, the amount of CPU and memory utilization that a piece of security software that we won't mention that Corey and I worked for in the past, potentially, the level of resources that it would take was astronomical from time to time. The joke always was I would start a scan, I'd go get a cup of coffee, talk to a few people, and then maybe by the time I got back, the scan was done and I could start my day. So that, in a nutshell, is the slowdown. And a lot of times the operator systems that have to control the downstream devices, and that's really where this comes into play. It's not so much the individual controllers themselves, where those are a target, and Allen Bradley and Siemens and other vendors of the controllers themselves are consistently trying to make them more secure, make them less a target for outside attackers, especially with the critical infrastructure focus that the federal government has put out there. The vendors are doing everything they can to secure those. Where it really comes into play is the operator being able to manipulate the flow controls or the fan speeds or this widget that is going to allow the system to run that much more efficiently or prevent damage further down the line. So it's the operator being able to run those controls. And if the underlying device, which in my experience in most manufacturing environments is somewhat underpowered, they don't necessarily buy the latest and greatest systems to act as operator controllers because they're also in industrial environments. They're subject to dust and moisture and heat and all these things that are going to make them go bad that much faster. So spending a lot of extra money for a little more CPU capability or a little more memory seems to be counterintuitive. So with all of that being said, any level of slowdown with security software that could potentially slow down the operator's ability to respond to a behavior within the manufacturing environment is really where that slowdown comes into play. It's not so much in the code itself, it's in the operator's ability to respond to changing environmental variables.
Bottom line, Sam, is that security tools historically have not been made to secure an OT environment. That's just the bottom line. And so if you think about it, if I'm a manufacturer for security tools, then I'm not, if this 1-2% is an OT environment, I mean, the market just historically has not been big enough. So that's why they're not going to spend time to customize their tools to be used in those type of environments.
Okay, amazing. So I am actually going to have one more follow-up question there, and that is going to be related to, again, the 5-second slowdown that we are talking about. So if I think more from the manufacturing executive perspective, okay, I am always trying to get as much OEE as possible because my customers are actually trying to push me that, you know what, I want you to produce this part at this specific cost. Now, let's say if I'm the manufacturer, I'm actually asking my either the machinist or the tooling guy or the guy who actually installs the line that, okay, I am looking for this specific OEE. I am looking for this specific cycle time. If I don't get this, then I am actually going to lose the order. Okay, so now I can see where that 5 second could be a significant impediment overall from the organization perspective, because in general, the manufacturing organizations, they don't understand how software development works. They don't understand how cybersecurity works. So yeah, so they are actually trying to push the business goals, but they need to understand the implications as well. So would you agree with this, that the greater push for OEE at this point of time, the greater push for optimization, the greater push for whatever you can really take out from your line is maybe driving some of these issues in the OT environment related to cybersecurity? Is it fair to say that?
It is absolutely fair to say that. I mean, it's driven by money, right? Because if they can make more revenue in that type of model, then yeah, that's going to be the driver, right? If they can meet these requirements, and if it costs you more to add security on top of it, then they're not going to do it. Because here's the thing, most of these companies buying it, they historically have not been asking for security because they already know security is just going to slow them down and ultimately cost them more money, because they have security on top of it. Then the systems are going to perform slower and you will lose those 5 seconds. So it's always been that trade-off. Now what is happening is critical infrastructure and OT environments are now being specifically targeted. And that's something that's changed in the last 10 years, and they've started to increase. because you take just simply a ransomware attack. A ransomware attack, if I attack a critical infrastructure or an OT environment, then I'm gonna get paid just that much quicker because of how critical it is. You can't recover that from backups. You actually need to have those systems functioning, and that's what you saw in Colonial Pipeline and these other attacks. Is that it's all about these ransomware hackers getting paid faster.
Okay, amazing. So yeah, I'm actually going to go back to the whole encryption argument. So obviously, I don't know how it is going to appear. Let's say if I'm standing on the production floor, and maybe I am standing in a facility where I have had, let's say, the ransomware attack. Some of my devices are infected. So how do I know if I may be infected at this point of time? What am I going to observe in the story? What did they observe?
So absolutely, with that particular incident, what happened was a couple of the devices. Most times when a device becomes encrypted, there will be a ransom note that comes up, whether it's dropped on the desktop or sometimes it'll even create a pop-up on the device. It just depends on which particular variant it is. In this particular case, it was a pop-up that they saw on the operating system. So the Windows-based device that's on the control floor that generally has a full screen application of their manufacturing application in place where they can choose different aspects of that. It actually caused that to minimize and pop up a ransom note on the manufacturing floor is how they were first informed of it. Unfortunately, that means it's already fully encrypted, that device. So at that point, it's not too little too late, but at the same time, it's gone beyond the point of being able to do any mitigation other than wiping and restarting on that end device.
Okay, so when you look at these devices, so obviously, if I get the pop-up, then I kind of, know that, this is probably already encrypted, this has the ransomware. So are they actually trying to block all of the input controls? And based on that, they are trying to alert the pop-up that, now you cannot do anything. I'm actually going to block out your keyboard. I'm going to block out your mouse or, whatever control you might have. Is that going to operate when I get the ransomware, or are they different depending upon the ransomware?
It's different depending upon the ransomware. So in this particular case, because the files that were necessary on the floor were drawings, DWG files, they were encapsulated in the encryption. So at that point, they were no longer able to manipulate those drawing files, which prevented them from being able to do their work moving forward. So they couldn't use that particular endpoint for any controls. Now, there are some that will do a full disk encryption and will essentially throw you into just a startup screen that tells you that the device is encrypted. You can't even log in to the device. So that's one of the more nefarious sides of it. And then if you get into the BIOS level or the boot record level encryption, then it's even more difficult. So there are varying degrees. There's some that will just encrypt documents. There are some that will encrypt separate files, Windows files, and it essentially runs the gambit from as simplistic as encrypting documents just to create annoyance and friction and to extract a little bit of money, all the way to encrypting at the boot record level and creating a complete downtime, which most of the more targeted nation state backed actors are really moving towards that degree of difficulty, so to speak.
What people need to understand, ransomware attacks today is not just malware being randomly dropped onto systems and encrypted. They are actually hacks. So what's happening in most of these is that the ransomware attackers, they are hacking in. If you have not been fully patched, they're exploiting some vulnerability in many cases. Once they get admin access into your environment, they're exfiltrating critical data to show, hey, we have your critical internal data, whether it be plans or confidential data, customer data, whatever it is. They steal that data, and then they systematically plan the encryption of those systems. So the last thing that happens is them dropping ransomware malware. The first thing that happens is they actually are hacked because they have not properly secured the organization.
Yeah. Okay, amazing, guys. So that's it for today. Do you have any last minute closing thoughts or remarks?
Thank you so much for having us. I could talk for another 4 hours about this. It's really a passion of mine because it affects so many of us. So thank you so much for having us on. Really enjoyed the conversation.
Yeah, same here. I just want the audience to realize that there has been a huge evolution in cybersecurity. Just that's on the IT side, and so even before OT was way behind as to how they were secured, that has actually gotten worse. Yeah, if we aren't consistently patching and locking down systems, then the IT side is going to always be vulnerable to attack, and it's going to lead to more critical infrastructure OT type of attacks. So we really got to strategize and catch back as an industry.
Okay, amazing. And my personal takeaway from this conversation is going to be, sure, I mean, you are going to have your business priorities. You are trying to reduce the cost as much as possible, but that should not be at the expense of people's security, cybersecurity, because you have obligation to your customers, you have obligation to your employees. So make sure you at least understand and take precautionary steps so that you don't have to shut down your plant and you don't have to get your customer and employee data stolen. So on that note, I really want to thank you for your time, guys. This has been a powerful conversation.
Thank you, sir.
Thanks.
I cannot thank our guests enough for coming on the show, for sharing their knowledge and journey. I always pick up learnings from our guests, and hopefully you learned something new today. If you want to learn more about Corey or Dave, head over to cyvatar.ai. It's cyvatar.ai. They can fulfill all of your company's cybersecurity needs. Links and more information will also be available in the show notes. If anything in this podcast resonated with you and your business, you might want to check other related episodes, including the interview with Dale Parmentieri, who shares his insights into CMMC preparedness and assessment nuances. Also, the interview with Bill Palifka, who shares his insights into low-hanging fruits for SMB businesses without breaking their bank. Also, don't forget to subscribe and spread the word among folks with similar backgrounds. If you have any questions or comments about the show, please review and rate us on your favorite podcasting platform or DM me on any social channels. I'll try my best to respond personally and make sure you get help. Thank you, and I hope to catch you on the next episode of the WBS Podcast.
Thank you for listening to another episode of the WBS Podcast. Be sure to subscribe on your favorite podcasting platform so you never miss an episode. For more information on growth strategies for SMBs using ERP and digital transformation, check out our community at WBS.rocks. We'll see you next time.